Hello boys and girls, welcome to Science in Daily Life with me, Sir Zamin. I trust that you are doing well and you are prepared for today's class. Can you recall what we would have done in our previous lesson? Yes, we would have discussed some electrical quantities. We spoke about current, voltage, and resistance. We would have stated that an ammeter is used to measure current, a voltmeter is used to measure voltage, and a resistor is used to measure resistance. Today, we will move on to kinds of circuits. Our objective for today will be to discuss the types of circuits. Let's move on. The first type of circuit that we will be looking at will be the series circuit. A series circuit has one path for current to flow. In a series circuit, when the switch is closed, all the bulbs will light. A break in the circuit will stop the current from flowing. Take out one of the bulbs, the others go out. If one of the bulbs is faulty, all the bulbs will go out. Therefore, a series connection of bulbs is not a good idea. One out, all out. Can you think of an example of a series circuit in your home? Or at a point in the year when we use a series circuit? That will be during Christmas time. An example of a series circuit will be fairy lights or the Christmas tree lights. You may recall your parents cautioning you when putting up these lights, because if one of the bulbs is faulty, then no of the other bulbs will light. So you need to be very cautious when handling fairy lights because of the series connection. Here we have a diagram of a series circuit. You can see it comprised of a battery, switch, and two bulbs. The two bulbs are side by side. They are in series to each other. Of course, the series circuit can consist of more than two bulbs. Once they are side by side, we refer to it as a series connection, because if you look at that diagram, you can see that there is only one path for the electrons to flow through. Therefore, you can even see that if there's a breakage anywhere along that path, it will stop the electrons from flowing. Therefore, electricity will not be produced. I will now like to direct your attention to a video on how to make a series circuit. Do enjoy. Welcome back, students. I do hope you were able to follow the steps shown in the video, and you will take the challenge to create a series circuit at home. When you would have created your series circuit, you can investigate the fact that if you remove one bulb, the others will not light. Do have fun doing that. Now, students, since we keep stating over and over that if a bulb is faulty or if there's a breakage in the pad that no bulb will light, it therefore means that we need to know what type of circuit we should use in our home. That type of circuit is called a parallel circuit. In a parallel circuit, there is more than one path for the current. For you to better understand this, please pay attention to the figure in front of you. In a parallel circuit, there is more than one path for the current. The figure shows a simple parallel circuit. When the switch is closed, both bulbs will light. Each bulb has its own branch of the circuit. The current from the battery divides at point A. Each bulb has a share of the current. These shares join together again at B and flow back to the battery. If you take out one bulb, what do you think will happen to the other one? If one bulb breaks, the other is not affected. Therefore, most lighting circuits in the home are in parallel. Now, students, let's look at another example of a parallel connection. If you use 2 bulbs and 3 switches, you can make a circuit in which each bulb is controlled by its own switch. S1 controls bulbs X and S2 controls bulb Y. The third switch, S, is a master switch. It controls the whole circuit. Neither lamp can be switched on unless the master switch is on. Try to trace the circuit path for yourself. Look at that diagram. Try and draw that diagram in your notebook and trace the path with your pencil. This master switch is similar to the main switch in your home. When the main switch is off, no appliance in the home can work. Now, students, I'm not sure if you would have experienced this at home. When your parents are leaving for a long time, maybe a weekend, or you guys are spending the night out of the house, they would more than likely turn off the main switch so no current can be flowed through. That would cause maybe an electrical fire if there's a faulty appliance and you are not at home. Similarly, if one of the bulbs in your home is faulty or it blows, the other bulbs in your home still continues to light. You don't have to go and replace all the bulbs, just that bulb that is faulty. So, students, we can conclude by saying that a parallel connection is the best connection to use in our home. Let me now direct your attention to another video. This video will now show you how you can make a parallel circuit. Do enjoy. Hi, boys and girls. So there is another activity for you to have fun with. When creating your parallel circuits, following the steps in the video, try removing a bulb and see if the other will light. Do enjoy your experiment. Please note, students, if you do not have the materials shown in the video, you may substitute. For example, you can use 2 paper clips for the switch. The video used LED bulbs. However, you may use any other bulb to carry out this activity. In addition, do have a parent or guardian supervising you when conducting these activities. My fun scientists, this has brought us to the end of today's lesson. We would have examined series and parallel circuits. I do hope you would have grasped the concepts taught today. Until next time, I am Sir Zamin. Have a wonderful remaining of the day.